This is Mary Peters. This is my Lab 1 Constant Velocity Motion Report for Physics 2211, Section M02. In this lab, I recorded a jar of chapstick rolling across my desk, moving at the same speed without changing direction. I tracked and analyzed the motion using Tracker. The main objective of this lab was to model the object using VPython by making the assumption that FNet equals 0. Ideally, the model provides a good prediction of the observed motion. I used Tracker to observe the motion of the chapstick jar. This motion was observed beginning with when the chapstick first touched the table, which was right here, and ending when the chapstick, right before the chapstick hit the barrier, which was right here. During this time frame, the net force acting on the chapstick is approximately 0 if friction is negligible. I used the first time frame in order to set the origin of the coordinate system. I set it at the center of the round chapstick cap, right here. I chose this to be the positive x-axis so that the object is moving in the positive x direction away from the origin. I took the center of the chapstick cap as the average position. So if we play this video, you can see the teal-blue diamonds represent the average position, and this data is graphed to the right. I used the calibration stick to record the diameter of the chapstick cap, which I measured to be 0.22 meters. This served as the length scale for the whole video. Time between frames was 0.034 seconds, and the total time for the motion was 1.504 seconds. To predict the motion through modeling, I used VPython. I used the mass of the chapstick, which I measured to be 0.16 kilograms. I needed the initial position of the jar, which I found by analyzing the x position of the first frame. So our initial, which was 0.012 meters, so our initial vector for the ball's position is 0.012 for the x component, and then 0 for the y and z components. In order to find the initial velocity, I found the average velocity, since velocity is constant throughout the video. I found this by taking delta x over delta t for the entire video clip, and I found it to be 1.971 meters per second. So our initial velocity vector was 1.971 for the x component, and then 0 once again for the y and z components. I set delta t as 0.01 seconds, which is small compared to the 1.5 second length of the video. The momentum principle can be manipulated to form the equation V final equals V initial plus F net divided by m times delta t. Because the velocity is constant throughout the video, F net was assumed to equal 0, which we plugged in right here. This would result in the final and initial velocities equaling each other. Because velocity equals change in position over change in time, the change in position can be written as the final position minus the initial position. Therefore, the equation initial position plus velocity times delta t can be used to predict the final positions. So let's run this simulation. When we run it, we can see that the chapstick moves. It begins just to the right of the origin and is moving in the positive x direction at a constant speed. The best way to compare this model and the Tracker experimental data is to plot both the position versus time data from each on one graph, which I did right here. The blue represents the actual Tracker data, and the red represents the model. As you can see, the VPython simulation is an excellent model for the chapstick's motion, and this confirms our assumption that FNet equals 0. For the what if question, I said, what if the orientation of the origin was changed so that the chapstick was moving in the negative x direction? So in order to show this change, I had to make my change the position and velocity, initial position and velocities, to be in the negative x direction. So I made the x component negative. So we can run this and see that the jar would begin just to the left of the origin and move the negative x direction at a constant speed. So what does all of this mean? The chapstick's actual motion was predicted well by the VPython model, where FNet was set equal to 0, because the chapstick jar moved at approximately constant velocity. For constant velocity motion, the net force acting on the object is 0. This implies that the object's velocity will change if the net force is not 0.